Welcome to Hexadecimal. Today we're going to look at how to convert a denary number into a hexadecimal. Remember, denary is just another word for decimal, the numbers that you use every day. And you can see in my table on the board I have the decimals on the top, 1 to 15, and the hex numbers on the bottom, 1 to 15. Now you'll see when the hex number gets to number 10, it changes to the letter A. And then 11 is B, 12 is C, until we get to the number 15. We don't go above 15, we always stay at the number 15. So let's see how this works. Okay, so if I have the hex number 3A, well, I look at my table, I can see the 3 is 3 and A is 10. If I have a hex number B, E, 5, I've got a B which is 11, an E which is 14, and a 5 which is the number 5. Okay, so why do we use hexadecimal? What's it all about? Well, computers don't use hexadecimal. It's people that use hexadecimal. Computers use binary, but binary can become quite complex with all them ones and zeros. So we have narrowed it down to hexadecimal to make it shorter, to make it easier to work with. Hexadecimal is used in error messages when we are coding. It's also used in colour mapping in HTML or in art software such as Photoshop. It's used in MAC addresses, and remember, a MAC address is an address given by the manufacturer to each device to identify it. So let's have a look at converting denary to hex. Before I go any further, I must explain that in your exam you won't have a calculator. So I'm going to show you a technique that is non-calculator technique, and I find this the easiest way. There are other ways and we'll explain them in a different lesson. So first of all, converting denary to hex, we have to convert the denary number into a binary number. So you do need to know binary before you learn this method. Then you divide the binary up into 4-bit sections. Remembering 4 bits is a nibble. We've got 8 bits, which is a byte. If we half a byte, then it's 4 bits, and that's called a nibble. So we convert each 4-bit sections into a hex, and then we put all these sections together. So let's convert the denary number 124 into hex. Well, remember, we've got to convert it into binary first. So to do that, let's put our table on the board. Right, so if I want to convert 124 into binary, I take the first table, look at the first table, it says 128. Now I've got to work out, will 128 go into my number 124? No, it won't, it's too big. So I put a 0 there. The next column is 64, and I say, okay, will 64 go into my number 124? Yes, it will, so I can put a 1 there, and I'm going to get 124 minus the 64 to see what we're left with. We're left with 60. Okay, so I now have 60, so I go on to the next column and I say, will 32 go into 60? Yes, it will, so let's put a 1 there and let's take 60, got 60 minus 32, and that is 28. Okay, so I now have 28, go to the next column. Will 16 go into 28? It will do, so let's go 28 minus 16 to find out what we've got left. We have 12 left, so go to the next column. Will 8 go into 12? It certainly will, so don't forget to put your 1s there. Okay, so we have 12 minus 8. What are we left with? we're left with 4. Let's go to the next column. Well, there is a number 4, so we'll put 1 in there, and obviously we've no numbers left now, so the other 2 can be zeros. So our binary number for 124 is 011111100. Okay. Right, so now I have my binary number, I am going to convert it into 2 nibbles because I've got 8 bits. So I split it down the middle. So we're breaking it into 2 nibbles. Okay, so 4 bits equals a nibble. So let's split that up. Here we've got our 2 bits. Okay, it's the same binary number. I've just split it in half. Now I want to make it easier on myself, so the left hand bits where we've got 16, 32, 64 and 128, I'm going to make them smaller numbers like the other side. So here we've got 1, 2, 4, 8 on both sides. So from here I can now convert it into a hex number. So let's have a go. We're looking for the ones, and we have a 1 under here, so I can put that down, so 4. We've got a 1 here, so I'll put 2. And we've got a 1 here, so I can put 1. And all I'm doing is adding them together. And that equals 7. Okay. And then do the same on the other side, so I have 8. I have a 1, a 4. I've got nothing in the 2 column and nothing in the 1 column, so I just add them 2 together, and that makes 12. Okay, so now what I've got to do now is just put them together. So if I put that down here, I've got 7, and if I have a look at 12, well, 12 in hex, remember, is a C, so I move that down there, but I represent it as a C. So the hex number is 7C. Okay, right, so let's have a look at this number. We've got 219. Okay, is a denary number. We want to convert it into a hex number, so we're going to convert it into binary. So let's have a look at the first column. The first column, we've got 128. Will it go into 219? Yes, it will. So I'm going to put a 1 there. So 219 minus 128 equals 91. So now I've got 91. I look at the next column, which is 64. Will 64 go into 91? Yes, it will. So take that away from 91. And that's 27. Okay, and then I'm looking at the next column. Will 32 go into 27? No, it won't. So I'm going to put a 0 there. Okay. Will 16 go into 27? Yes, it will. So I put a 1 there. And I'm going to say 27 minus 16 equals 11. Okay. So will 8 go into 11? Yes, it will. Put a 1 there. So I'm going 11 minus 8 equals 3. Okay, so I've got 3 left. Will 4 go into 3? No, it won't. So 0. Will 2 go into 3? It will. So 3 minus 2 equals 1. Okay, and I have 1 left, which will be the last column. So the binary number for 219 is 11011011. Okay, so I need to split these into nibbles now. So let's split that into a nibble. And what we are going to do is just take them apart, change the left hand side numbers so they're lower numbers. So we've got 1, 2, 4 and 8, and then we work out what the hex is from here. So we have underneath the 8, we have a 1, so we can include that. We have a 1 under 4, so we can include that. And we have a 1 under 1, so 8 plus 4 plus 1 equals 13. Okay, now do the same on the other side. So I've got an 8, okay, and I have a 2, and I have a 1. Add them together, and I have 11. So on one side I've got 13, so I represent this, if I look at my table, by the letter D. And if I put that next to it, 11 is B. So the hex number, if I put them together, is DB. Right, so that is hex, and you can obviously get onto bigger numbers with more bits, but that's for another day. Okay.